Hello everyone. In this video, we'll discuss few more previous year questions from this particular 13th and 15th April sessions. I have discussed few questions from these sessions, so you can check that part one of this particular video. And we have discussed few questions. Now let's discuss few more questions in this particular 13th and 15th April sessions. So yeah, now let's see. Let's start with this. So here they are asking compound A from the following reaction sequences. So they have given first, they have given reagents also, and final product they have given. We just need to find what is the compound A. So let's start C. If you start with phenol, the one case is here you should know is in case of phenol there are, it depends on the solvent. Like in case if you take in the presence of Br2 in the presence of CS2, we'll get ortho and para products. We'll get these two. Ortho, OH. Here it will substitute on para, and again we'll get one more at ortho product. Right? But when it when if you use the Br2 in the presence of water, it will substitute on all ortho and para positions. Then we'll get this 2,4,6 tribromo-phenol. Will get this, will get 2,4,6 tribromo, tribromo-phenol. We'll get this 2,4,6 tribromo-phenol. But when it comes to aniline, you should know this difference. But when it comes to aniline, it is far more reactive than phenol. That's why it won't depend on the solvent, what type of solvent you are taking, it won't affect. So if you take anything like in the presence of CS2 or Br2 in the presence of water, we'll get 2,4,6 tribromo aniline only. So let me write it over here. So if you take this Br2 in the presence of CS2 or Br2 in the presence of water, we'll get only one product, that is this. Because due to its reactivity, this bromine will attack on ortho and para position. We will get this 2,4,6 tribromo aniline. So you should know the difference between these two. So they have given for your confusion, they have given these two, phenol and aniline. We can't prepare this from this benzoic acid and salicylic acid. So yeah, if you check over here, if you take phenol, then we'll get in the presence of CS2, we'll get one of these, right? So let's take major. This is major over here, and if you consider, if you treat with this NaNO2 HCl, so you can clearly it shows that this is like it will form diazonium chloride, right? When you have this aniline, then only it will form, it will do the reaction, it will move forward, right? So the aniline is the correct option. So we have got this. After that, they have given this reagent NaNO2 HCl, right? Let me just rub this. I hope you got this right. So this is an important point over here. And yeah, now let's see. Here we have got this, and then again they have given this NaNO2 HCl. Then this will convert to benzene diazonium chloride N2 plus Cl minus. If you take phenol, it won't give, right? Like we'll get only ortho or para position only. We won't get this. If you see the product also, we have three bromines. So the chances of taking aniline is more here. And then they have given H3 PO3. It just simply replace this N2 plus Cl minus with hydrogen. Then we'll get this simple 246 tribromobenzene. So we have got this right. So phenol is not correct option. Aniline is the correct option over here. This is the concept is important over here, or else you may get confused, right? So yeah, you can see the solution here also. And now let's see one more question. That is, they have given this CN. Let me write it. C triple bond N, right? And here it is double bond. And they have given this OH SH. Here, due to its less electronegative, this sulfur will give electrons, right? It will attack on this particular carbon, and this double bond shift towards here. This sulfur will attack on this particular carbon, and this bond shift towards here, and it makes here double bond, and one of the bond between C triple bond will shift towards nitrogen. Then we'll get this, right? OH here, and SH. S will get positive charge over here, and then this carbon, and this is the carbon is this one. Let's give numbering, it will be easy for us to write the product, right? 1 2 and one more carbon, 3. C double bond N negative, right? And then between 2 and 3 we have double bond. So now here again, like, this will shift towards here, and it will make triple bond. And yeah, this double bond will abstract this hydrogen, and this will get, finally we'll get the product like this. OH, here it is S, sulfur, and it abstract this hydrogen, right? It will form this, and here it is C triple bond N. So yeah, we'll get this in between sulfur, and here it is Cn, and here it is OH. Option 1 is the correct option. So you can see the solution here. And the next one is, the next question is, given below are two statements. One is labeled as this assertion A, and one more is reason R. So let's read first assertion A. Order of acidic nature of the following compounds. So whenever if they ask about acidic nature, you should remember this. Acidity is Acidity is proportional to electron withdrawing groups. If electron withdrawing groups increases, then acidity also increases. Sorry, and it's proportional to its stability of its conjugate base. So just try to write its conjugate base whenever if they ask acidity, right? And yeah, now let's check. Here we have this phenol, like OH groups are common, but just check this: CH3, fluorine, and chlorine. CH3, as we know that this is electron donating group, so this C is less acidic as compared to this, because fluorine are electron withdrawing groups. As we know that electron withdrawing groups increases the acidity, and this both shows minus I effect, right? So here it is Cl. Let's compare these two now. OH F. As we know that inductive effect depends on distance, right? So if with distance, inductive effect also decreases. So we can say that this is more acidic than compared to this. As we know that anyways, like, it is more electronegative, but due to this inductive effect that depends on distance, so due to that reason this is more acidic as compared to this one. So let's see. A is greater than B is greater than C. This assertion A is correct. Let's see the reason what they have given. Fluoro is strong electron withdrawing group than chloro. Yes, this fluorine is strong electron withdrawing group than chlorine, but the thing is that due to inductive effect, that is dependency depend on the distance. So that's why, that is the reason why this is more acidic. But they didn't mention here, right? So option reason are also correct only, but this is not the correct reason for this particular assertion here. So both A and R are correct, but R is not correct explanation of E. So this 3 is the correct option, right? So now let's see one more question. You can check the answer here. So let's see this question. 1 bromopropane is reacted with reagent in list 1 to give products in list 2. So they have given this 1 bromopropane. Let's draw that. CH3, CH2, CH2Br. This is 1 bromopropane, and let's treat with different types of reagent. First is alcoholic AOH. As we know that alcoholic AOH undergoes elimination reaction, right? It undergoes elimination reactions and it gives the product alkenes. Let me write the product here. We'll get this CH3CH double bond CH2. This undergoes elimination reaction and we'll get alkenes. So option A is alkene, right? Option A is 3. So we have only one correct option. You can take the option correctly. No need to see, but yeah, let's take all these also. And in the presence of this alcoholic cation anyways it will undergoes substitution reaction only. We'll get nitrile. This will substitute over here and this bromine will be removed. CH2 CH2 CN will get nitrile. So B is for 1. And AgNO2, this also undergoes this substitution reaction only. We will get this nitroalkanes. CH3 CH2 CH2 and O2 will get. This is the nitroalkane. So option C is 4, right? And D is simply just remove AgBr and we'll get the ester. So yeah, option 2 is the correct option. You can just recheck. You can see the solution here also. So that's it for this particular session. So in part 1 I have covered few questions from this particular JEE Mains previous year question. These are questions from 13th and 15th April sessions, and I'll cover few more questions from different sessions. So this is the part 2 of this particular video solutions, and you can see the part 1 also. I'll give the link in the description box. And yeah, let's meet in my next video, and I'll try to cover few more questions from different sessions. So yeah, just practice well and take care of yourself. We'll meet in my next video. Bye.